So question here is e raised to the power x plus e raised to the power y equals e raised to the power x plus y, and then we have to find dy by dx. Now before finding differentiation, we need to simplify this, and for simplification what we are going to do is to write this as e raised to the power x, this as e raised to the power y, and we can write this using laws of exponent as e raised to the power x multiplied by e raised to the power y. And the next step, in order to make this as 1, we are going to divide both sides by e raised to the power x into y. So this is e raised to the power x into e raised to the power y. Same here, it is e raised to the power x into e raised to the power y. Dividing this as well with e raised to the power x into e raised to y. So I can say this get cancelled. Here e raised to the power x will get cancelled and e raised to the power y in this case. Now we can write 1 over e raised to the power y as what? E raised to the power negative y. Similarly, I can write 1 over e raised to the power x as e raised to the power negative x, and this is 1 over here. Now we are going to differentiate both sides with respect to x. So on differentiating this with respect to x, this will result to give you e raised to the power y, and by chain rule it will be minus times dy over dx. Now for the other part, this should give you what? E raised to the power negative x, and for x from the chain rule is minus 1. That's why I placed a minus here, which is equal to 0. Now, in order to find dy by dx, we are going to isolate dy by dx. And for that, if I write this as dy by dx and transposing this first to the right hand side, it should give you positive e raised to the power negative x, that divided by this, which is negative y e raised to the power, negative e raised to the power negative y. Now we can further apply laws of exponent to write them in the simplest form. The minus sign will be in the numerator. This divided by this will be what? Same base is divided. So on adding power, we get this as the answer. So we can write dy by dx as this. So this will be the answer in this case. The question here is if a plus bx times e raised to the power y over x equals x, then we need to prove that x times d square y over dx square equals a plus a over a plus bx whole square. Now, before differentiating, we are going to apply log on both sides. So on the left-hand side, we'll get what? This is log A into log B, right? This is A and B. So we can say that this would be give you log A plus log B. So this is log A plus log B, and B is what? E raised to the power y over x. And on the right-hand side, it is x, so it's log x. Now I'm going to transpose this to the other side. So we can write this as what? This is log e raised to the power y over x equals, this is log x minus log a plus bx. So this on applying another property of log, we can say that it will give you y over x times log e. Log e is 1, but we can reduce it in the next part. So this is log x minus log a plus bx. Now, since log a is 1, so we can eliminate this. And now we are going to differentiate both sides with respect to x. So y differentiation is dy by dx. So it is x times, by applying quotient rule, x times dy over dx minus x differentiation is 1 and y as it is, that whole divided by x square. So I can write 1 over x square. On the other side, log x differentiation is 1 by x. And from here, we are going to get this is 1 over a plus bx by the property of log differentiation, and by chain rule a plus bx differentiation is what? B. Now in order to simplify this, first we are going to transpose x square to the other side. So this is x square times, and on the left hand side on taking LCM, we'll have x times a plus bx, and this result to give you 1 multiplied by a plus bx and minus b multiplied by x is minus bx. In fact, this get cancelled over here. Now for further simplification, we are going to find the second order. No, we are going to write this as it is. And then in the next step, we'll find the second order differentiation. This is minus y. So we are left with x times dy over dx minus y equals, this is ax that divided by a plus bx. Now applying differentiation both sides with respect to x, x differentiation is 1. So this is 1 times dy over dx plus this time x as it is, and the differentiation of dy by dx is d square y over dx square, and this is y differentiation is dy over dx. In fact, this get cancelled only. So dy by dx and this get cancelled. And then on the right hand side, we have this. So applying quotient rule over here, ax differentiation is what? A, and that multiplied by a plus bx, and we'll put a minus sign. We'll write ax as it is, and the differentiation of this is what? This will be b. So we can write this as abx. One more time, ax as it is, and the differentiation of this is what? B. That's what I wrote, abx, that whole divided by the square of this, which is a plus bx whole square. So now what we are left with, on the left hand side, we are left with x times d square y over dx square, and on the right hand side, on opening this bracket, we are getting a square plus abx, and there's a minus abx over here, that whole divided by a plus bx the whole square. Now I can see that this abx and abx get cancelled. Now I can see this is what we need to prove, that is x times d square y over dx square as square of this, right? So this is how we prove this question.